Good morning, everyone. I am Andrew, Embedded Processing FAE for Texas Instruments, and I am currently handling the Southeast Asia region. Today, I will take you through TI's powerful and versatile microcontroller family, specifically the MSP-M0 and our application-specific MCUs, which is the C2000 family. So we'll begin with the MSP-M0, our scalable ARM Cortex-M 0 Plus MCU that redefines cost optimization. And then we'll move on to the C2000 series, built for real-time controller, high-performance processing, and system integration. And we'll also touch on our ecosystem, tools, and support that makes the development seamless from prototype to product. So what makes the MSP-M0 family unique? First, our cost structure is unmatched. Starting at just 16 cents per 1,000 units, it brings integrated analog and digital features into one compact device. And you're not just saving on component cost, you're saving onboard space, power budget, and supply chain complexity. And so it's the perfect blend of performance and price. Next, we'll touch on our very highly scalable portfolio here. The MSP-M0 family spans 10 plus pin-to-pin compatible packages, from tiny 2x2 millimeter QFNs to more featured device. And here, you can see our naming convention for our M0 lineup. So first, you will see the M0C, which is our lowest cost MCU solution, which is our starting at just 16 cents per 1,000 units. Next, you have the M0L, which is our low power solution. And finally, we have the M0G, which is our highest performer. And also, you will have access to our M0 selection tool, where you will be able to select your M0 based on your specific needs, such as clock speed, ADC, DACs, and other requirements that you might have for your products. So next, I would like to talk about our M0C, which is a very popular product that we have here in Thailand. Yep. So let me introduce you to the MSP-M0C 1103 and 1104. Our most cost-optimized device in the MSP-M0 portfolio. These MCUs are built on a 24 MHz ARM Cortex-M 0 Plus core and offer just the right feature set for your cost-sensitive applications. This device has up to 16 kilobytes of flash, 1 kilobyte of SRAM, and a full-featured 12-bit ADC with 10 channels and internal references. Multiple 16-bit timers, for control and timing applications, and a mix of UART, SPI, and I2C with fast mode plus support. It even includes a CRC accelerator, SWD debug interface, and ultra-low power operation, running from 1.62 volts to 3.6 volts. And its operating temperature is negative 40 degrees to 125 degrees Celsius. So with 10 devices and options on 6 of the smallest MCU package on the market, including the aforementioned 2x2 millimeter no-lead variants, this series offers unmatched cost, size, and simplicity. So if your goal is to do more with less, this is what you want to pick. Yep. So this tiny 8-pin 2x2 millimeter package has 6 GPIOs, and compared to the more common 8-pin SOIC, it's 7.35 times smaller than our competitors. But just for reference, I would like to just simply think it's smaller than a grain of rice. Yep. So one of the key advantages of the MSP-M0 MCU family is just how broadly it can be applied across any industries and equipment. So let's start on the left with building and factory automation. Applications like smoke detectors, gas sensors, PIR and garage sensors, and field transmitter all benefit from the MSPM0 compact size, wide temperature support, and integrated analog for signal sensing and condition. Next, in appliances, we're seeing MSPM0 used in smart coffee machines, power tools, robotics vacuums, and dishwashers. These designs benefit from the integrated PWM ADC for sensing current and voltage, and low power consumption during standby. Then finally, in personal electronics, MSPM0 is a fantastic fit for TWS earbuds, styluses, electric toothbrushes, shavers, printers, and wireless chargers. Its tiny form factors and fast wake-up times make it ideal for battery-powered consumer products. Now, on the right side of the slide, we see 4 key subsystem level use cases. So first, we have the I/O expander, where MSPM0 provides GPIO, SPI, I2C, and UART expansion to your main MCU. And secondly, ADC to communications interface. The MSPM0 samples analog signals and forwards them through your preferred comms protocol. And third, as a power sequencer, it can monitor up to 16 inputs and control GPIOs with very precise timing. And finally, we have the system startup and configuration controller. MSPM0 can manage initial system setup via I2C, UART, or SPI, then handoff control or enter deep shutdown mode to save power. So whether you're building a full product or looking to simplify your system, MSPM0 offers flexibility, integration, and cost efficiency all in one. Yep. Next, I would like to talk about our software side of things. So first, the entire MSPM0 family of MCUs is equipped with a unified software development kit called the MSPM0 SDK to help make development easier for users. Rapid generation of custom code using a graphical system configuration tool called sysconfig. If you sign up for our MSPM0 hands-on workshop tomorrow, you will see and get to experiment with this in firsthand. This tool will be used to configure GPIOs, timers, using a GUI and then it will generate real-time code.c and header files for you. So, as for integrated development environment, the MSPM0 family of products support not only TI's own CCS, but also supports third-party IDEs from Kale and IAR. Furthermore, for simpler applications, TI's own MSP0 Code Studio is an IDE used to program the MSPM0 with the use of block diagrams without writing a single line of code for simpler applications. And the same is true for the emulator, in which MSPM0 is supported by TI's own emulator, the XDS110, but also by most third-party emulators such as the Sega J-Link. And in terms of production programming, UniFlash is a software flash programming tool, and MSP Gang, the production programmer. And finally, all of this will be integrated into our MSPM0 Launchpad development kit, which allows you to quickly evaluate the basic functions of MSPM0 without having to make a PCB. So now I want to direct our focus to this specific tool, which is called the MSP0 Code Studio. So let's take up so this is one of our most exciting additions to our MSPM0 ecosystem, the Zero Code Studio. So this is TI's graphical configuration tool designed for developers who want to get their system up and running quickly, even without writing a single line of code. On the left, you can see the development flow here. First, you simply place the building blocks. Choose from a wide variety of digital, analog, and communication peripherals, and combine them with logic or control blocks like loops or triggers. It's all drag and drop. So you can see here, you can just add a block, and then you can manipulate them into an infinite or a for loop, and then you can program the MSPM0 using block diagrams only. Next, you will experience a guided development journey You can start with a demo or an empty project, and the tool walks you through what to configure and how to wire it all together. And finally, you deploy it to your device. Zero Code Studio generates the executable files, the header files, and the .c files as well. Compiles it automatically in the background and flashes it directly into your hardware. Yeah. And the final build of the software will contain the final header file and the C file, allowing you to plug it into your other projects for more elaborate applications. And next, I want to talk about sysconfig. Following the Zero Code Studio, let's talk about the sysconfig. It's a more advanced, developer-oriented tool that's deeply integrated into TI's Code Composer Studio. Sysconfig is a simplified configuration tool designed to streamline both hardware and software, helping developers to get their system up and running faster, with fewer bugs and better maintainability. And on the left side of the screen, you can see a wide range of peripheral, on the right side, I mean. You can see a wide range of peripheral modules, everything from GPIOs and timers to ADC, UARTs, and even system-level settings like clock sources. So you can configure everything from pin multiplexing to peripheral options. And sysconfig will automatically validate your setup and generate the necessary C and header files. And here's the best part. It works both online and offline. So whether you're using the cloud-based tool or our CCS, sysconfig gives you consistent behaviors and results. In short, this tool takes the pain out of low-level initialization and helps you focus on what matters, developing your own logic and algorithm. So what can sysconfig do? So first, it's very easy to use. With just a few clicks, you can add or remove hardware peripherals, configure clocks, enable interrupts, and set up your communications protocols like UART, SPI, and I2C. The UI is very interactive, intuitive, and it gives you real-time feedback. So if something doesn't line up, if you have pin conflicts or unsupported combinations, it will flag it right away so you can fix it before it becomes an issue in your development. And next, which is the deployment to device. Sysconfig automatically generates a clean C source code and header files in real time, which you can plug directly into your CCS project. Whether you're building from an SDK example or rolling your own stack, these generated files serve as a solid, validated foundation. So you can see at the bottom right of the slide, files like TI, MSP, DL config. These files are produced instantly as you work through the GUI. And the result, you configure your system faster, reduce errors, and maintain a much cleaner code. Sysconfig doesn't make your life easier. It speeds up your time to prototype and production. So let's switch gears a little bit into real time. C2000 MCUs. This is our real-time application microcontroller called the C2000. The C2000 MCUs are purpose-built for systems that requires precision, speed, and deterministic control. We're talking motor control, power conversion, automotive, and industrial applications. So where is C2000 real-time control? So you can see that C2000, it's present in every application that requires real-time motor control and digital power control. Yep. C2000 delivers high accuracy analog, math acceleration, lockstep safety features, and AI-ready compute power. So whether you're So here is our, here you can see our roadmap here. So the solution is starting at less than $1 for this F28 C2000 MCU here. From our low cost to series to high performance multi-core platforms like F28 P65 here. C2000 delivers high accuracy analog, math acceleration, and AI-ready compute power. And next, I want to give you some overview of the C2000. Yep. So here, you can see that the C2000 has a analog signal chain, which is the sensing, process, control, and then the interface. So here, first, for the sensing, the C2000 comes equipped with 12 to 16-bit ADC and up to 24 channels. Full analog comparators with built-in DACs, a quadrature encoder, and capture logic. For processing, the C2000 comes with a floating point DSP, configurable up to 925 MIPS. And next, for control, it has up to 32 outputs, tightly coupled with sensing domain for fast response time, and buffered output DACs. And finally, for the interface, it has supports CAN, CAN-FD, LIN, UART, SPI, I2C, PM bus, USB, and 10 Ethernet MAC and EtherCAT as well. And with over 25 years of experience in this field, C2000 will give you industry-leading performance when it comes to latency and efficiency. Yep. So next, I want to touch on the ecosystem for the C2000. So here, I want to touch on the C2000 ware. Similarly to the MSP-M0, we have our application-specific software development kits. First off, this is the baseline for developers that want to get started with the C2000. And next, we have our SDK for application-specific, such as digital power control and motor control as well. And furthermore, this also supports the CCS and sysconfig. And if you want to get started and want to know more about the onboard peripherals that the C2000 comes equipped with, you can also visit our Resource Explorer for more information, and as well as pre-written labs and documentation on specific features for the C2000 as well. Yep. So as for the EVM, we have the launchpad, launch with the control card, and then for some more specific applications, we also offer application kits for your reference design as well. Yep. So now let's look at how easy it is to get started with the C2000 real-time MCU family, especially if you are new to the ecosystem. TI offers a full suite of entry-level development tools that allows you to explore device capabilities without the need for complex or costly hardware. So on the hardware side, we have several low-cost options, which is the first is our Launchpad for standalone evaluation of the performance of the C2000. And next, you can pair the Launchpad with a booster pack for expanding its functionality. And finally, you got the control card with the docking station for a more modular, reusable setup. So all of these kits comes with an onboard debug probe, so there's no need for extra hardware to start programming or debugging. So for software, we provide the Code Composer Studio, our no-cost IDE available for both local installation and cloud-based development. You will also have access to our C2000 Wear SDK, which includes drivers, device-specific code example, and diagnostic libraries for functional safety applications. So whether you're building your first real-time motor control loop or exploring advanced signal processing, the C2000 ecosystem is ready to support you right from day one. So, but what if you're already familiar with motor control and our C2000? So for those that are already familiar with our C2000, this is where the advanced level of the ecosystem truly shines. So once you move beyond evaluation and prototyping, we offer reference designs tailored for real-world applications. These include complete design, tested software projects, and system-level documentation. So you're not starting from scratch when you're developing your product. So you can see on the example on the left, This is a high-efficiency power conversion board with a corresponding debug probe and software stack. Everything here is built to be production grade. For custom designs, TI also offers hardware design guidelines and simulation models, helping you optimize your layout, validate your performance, and meet safety or EMI requirements. And just like at the entry level, you're supported by our Code Composer Studio and C2000 Wear SDK, either locally or in the cloud. So whether you're building motor drives, digital power system, or real-time industrial controllers, the C2000 Advanced ecosystem gives you the tools to build fast, build right, and build with confidence. And so now that we have gone over the ecosystems and the product lineup of the MSP-M0 and the C2000, how do you select a board that is right for you? So here, our MCU selection tool helps you compare the performance and as well as our reference design. Yep, here you can see the MCU selection tool helps you compare performance, package, features, and price side by side. So here you can see that you can filter the according to your needs. So M3, M0, and then you can also filter using based on how much flash memory you need, what clock speed do you require, and then you can select multiple MCUs and generate real-time comparison tables for your consideration. And on each of these links, you will also see comprehensive MCU information regarding performance, features, and pricing. Yep. So to tie it all together, let's talk about reference design, a very powerful way to accelerate your development process. So what you see here is an example design for a cordless handheld garden tool. Keep in mind this doesn't only apply to MSP-M0 or C2000. This is one of the block diagrams that my manager Eddie was showing before. You can find this on our website. It's under the application section. You click on it and you will see this block diagram here. And based on your need, you click on the digital processing. For example, for this one, I'm clicking on the digital processing portion of this block diagram, and it will show me the recommended designs on recommended MCUs that I might want to be interested in for this design. And not only it gives you the recommended products, it will when you click to the reference design tab, it will also give you the recommended design for this portion of the system as well. So with all these options, you don't have to start from a blank canvas. You get schematic, layout files, firmware, and technical notes all tested and validated by our engineers to help you build faster and build with confidence. Whether you're prototyping or preparing for production, these designs are here to give you a serious head start on your development. Yep. To wrap up this portion of our MSP-M0 and the C2000 presentation, I want to leave you with a resource that brings everything we've talked about into one piece, which is called the MSP-M0 and C2000 Academy. Inside, you will find our comprehensive documentation on the architecture, peripheral modules, and software integration, in-depth explanation of how MSP-M0 and C2000 works, backed with use cases and technical insights. And most importantly, hands-on training labs that guide you through core features like CRC, DMA, flash, and power modes. So whether you're brand new to TI MCUs or a seasoned developer looking to push the limits of low-cost embedded control, MSP-M0 Academy equips you with the knowledge to move fast and build smart. So today we've explored the power of TI's scalable MCU portfolio, from the ultra-affordable and feature-packed MSP-M0 family to the C2000 real-time control platform. We've seen the development tools, the ecosystem, reference designs, and the training resources that makes it easier than ever to go from idea to implementation. So at TI, we're not just providing MCUs. We're providing solutions, system, and support for whatever you're building next. Thank you for your time, your attention, and your curiosity. I'm Andrew, and I'll be happy to take any of your questions. Okay. Oh.
Hello.
Hi.
I ever designed for the chopper image before. I really impressing about your chip. And I have a question. When you're starting to work with your chip and you have a training because it's a not simple way to the programming and do install and it's a development.
Yeah.
And you have a how support us if we want to go to design on your chip.
Are you asking about our available resources?
Yeah, resource supporting about the training, how do you design the chip?
Yes. So, is there a specific chip that you are interested in? By the MSP-M0 and the C2000. So, regarding the support, so if you go back to where you are picking the chip, you will find the documentation for this chip. So, say if you're interested in this MSP-M0 L222, you will find the design files for this chip, and then once you're done with that, you can go to our MSP-M0 Academy. It's built into CCS, or you can visit the TI Developer Zone to read the documentation on the MSP-M0 here. Does that answer your question?
Just to add in, one more thing is that you can sign up for our hands-on training tomorrow. Tomorrow we'll be here to have a hands-on M0 workshop conducted by Andrew. So that we'll have a half-day session at this site, okay, where you can do a hands-on to get your development started on M0. Yeah. So we will conduct training, and we have a lot of resources online. We have our academy, we have our videos, and also you can look for us, look for TI for support.
Yeah. Okay. Any more questions?
Okay. I have some question about C2000 about actually I have a problem about processing the data about imaging. I constantly choose C2000, use your library, your hardware to do that. If something change or something cost, I cannot move to another. So right now, for my design, I choose CRPD or FPGA to processing the data, not for, because I afraid supply chain disconnect or software disconnect. If you, may I ask you, in the future you can provide the C2000 library for free or open hardware or cannot portable to another, because I fear about cannot possible to port this code to another hardware.
Yeah. So you're talking about the like the motor control library from C2000?
No, I think image processing, because motor control, I think processing is powerful, but for the image processing,
image processing,
more bandwidth.
So you're talking about the image library?
Yes.
Library code from TI. Yeah. So okay. So I address a few concerns. So they're saying that the library from TI we provide, but it's not portable to other processor or other company. And you worry about supply chain, right?
Yes.
So first thing is the fundamental problem of supply chain. Let TI fix it for you. We have a lot of capacity. We built in-house. 2 years ago, and our old products maybe outsourced to foundries. We have less control. So maybe we had supply chain problems last time. But now that we do in-house, we have control, and we have less supply chain problem, and we also hold inventory. So the fundamental problem of the supply chain, let TI fix that for you. Okay. Yeah. In terms of the code portable, right? Some parts of our code is available in C, the upper layers, and that one is in C code. So you want to port over to any other like ARM or other processor is possible.
Yes, and library from hardware another branch.
Yeah,
too. Yes.
but there'll be some library that we put inside the ROM code. Technically, you can port over. Like image library, I'm sure there's some like open source similar equivalents for those functions they can port over. But the key thing is that when you run it on an ARM, it's going to be different from running on the C2000. Because the architecture is different, so the efficiencies will be different. So yeah, so technically you might be able to find those codes in open source already. Like image library is very common now in open source, but the efficiency will be different. Yeah.
Yes, but point is not only the software, hardware that control too, because of sometimes driver is quite difficult to move. That's why.
Yeah, if it's from the TI driver, is the image library from TI driver,
Yes,
it's
there's
an
hardware.
assembly and
Yes,
it's hard coded, right? Some of them.
DSP core, yes.
Yeah.
no problem.
So that one, yeah, honestly, that one cannot be ported over. Yeah, but if you want a similar function, you have to find the open source code to
Yes,
in
very
C.
easier. That's why if right now I use the more open. If I use control to the CI library for the hardware accelerate, it cannot move. It's very struggle for me to move.
Yeah. So don't move, stay with TI. Yeah, because the library is optimized for the hardware accelerator on the C2000, so it works best. When you move it to the ARM, maybe it can work, it should work, just the efficiency is different. Yeah.
Yeah.
Right. Thank you for the question. So hopefully you can trust TI that we can fix the supply chain problem for you. Then you don't have to move to other processor. Yeah. Right. Thank you for the good questions. Yeah. Another question? Yeah.
Are you asking if the MSP M0 is available on MATLAB and Simulink?
I don't think so yet.
Yeah.
Yeah. Not yet. Yeah.
Not yet. Yes, it's on the roadmap. Yeah.
Yeah, because the one is controlled by MATLAB, so I don't know whether they want to support it.
Yeah.
Yeah, but if MATLAB want to support it, or TI will partner with them for it.
Yeah.
Regarding C2000, you have one page mentioning about buffer drag. What does it mean? Can you get back to? No. Yes, this one. You see the left side, and the second, yeah. What does it mean? Buffer output drag. You need extra module or for DAC, right?
Yeah. So when the output of the DAC, right, it's like one problem with the DAC is like you will have to like periodically write to the DAC to get the output waveform, right? Let's say you want a sine wave, they must keep writing until it goes there. Then your processor is very busy. Maybe every 200 milliseconds, right, very busy. What you can do now is you can pump the whole database. One set of data, 16 data, so you pump into the buffer. Then for the next 16 times 200 milliseconds, you don't have to write to the DAC. Then the DAC will take care of the next 16 data.
But it doesn't have a DAC embedded in.
Oh yeah,
inside.
we have. Some of the C2000 have DAC. Not all. So because this is a whole C2000 family, some C2000 have DAC, some don't have. Yeah. So those with DAC will have the buffer. Yeah.
Yeah. Thank you for your question.
Very good questions from you guys. You guys are really quite familiar with our products already. Yeah. Any other questions?
I think we can move on.
Okay.
Yeah.
Question? Yeah.
Please.
You have any microcontrollers with USB? Yeah, it's difficult to find microcontrollers with the USB in the TI. I mean, maybe in MSP G0, it might be coming with the USB.
I think we don't have eUSB in our plans. eUSB is more like processor class device. Then we have eUSB on the processor class. But in the MCU class, the USB is usually with the 5 for the external. Yeah, so I don't think we plan for that. So you have a use case for microcontroller with eUSB.
Oh, no, not eUSB, normal USB.
Or normal USB for microcontrollers?
Yes.
Oh yeah, we have a USB coming up. USB 2.0 full speed microcontrollers with USB on the M0.
Because when we search, it's like so expensive compared to other competitors.
Yeah, because
We have found some microcontrollers with the USB, but it's expensive than the other competitors.
yeah, okay. I think we can follow on that. We have some right now. Maybe the older ones are very expensive, but we have a new device coming up with USB on the MCU, but up to full speed. Yeah, so that we have some coming up. So those will be I think it should be this year, right? The USB, we are launching it this year. We'll be launching it this year, the USB option. So then we can follow up with you on that device.
Support USB Type-C?
Oh no, Type-C will be, Type-C you're talking about 3.0 already?
Yeah.
Yeah, 3.0 MCU class cannot do Type-C, cannot do 3.0. For USB 3, we need very high performance processor, like the AM64. Then those are like in the $10 range. And it's just a processor, it's not even an MCU. You need the external flash, external DDRs. So for USB 3, because of 5 gigabits per second throughput, we cannot put it onto a low-cost product. Yeah, it will be an expensive product for USB 3. But USB 2 at full speed, which is 12 megabits per second, we can put it in MCU class. In fact, the high speed 480 megabits per second, we also can put it in MCU class, and that's further out on our roadmap also. Yeah.
With the USB 2.0, what may be the expected cost, the minimum starting?
2.0 full speed, less than should be in the dollar range.
Less than or more than $1?
Because we haven't launched, so
Okay.
I don't have the pricing yet, but it should be just about 1.0 plus minus there, all right, around that range.
Okay.
Yeah,
Thank you.
yeah, thank you. We will follow up with you on that, yeah. Is another question from behind? Yeah.
Yeah, hello, good morning. So I'm looking at it on a cost point of view. So initially, yeah, on the 2 millimeter package, you say it's like 16 cents, right, per unit,
Yeah.
per K unit. So does this involve the overall packaging and all the silicon costs? Do you build this also in-house within the TI manufacturing sites, or you do subcon on these packages?
Oh, okay. So TI, we only make the wafer, the IC, the
That's
wafer.
right.
The packaging we buy. We buy the we have packaging suppliers that we buy from, and then we do the assembly and testing.
Okay.
Yeah,
So
we-
sometimes you do it.
We have assembly and test factories in Taiwan, Philippines, Malaysia.
Still within the TI.
Oh yeah, yeah.
factories.
Assembly testing is within TI. Yes.
Okay, so the 0.16 is the overall packaging cost, including the silicon. Is that what you mean?
Yes, the selling price. Selling price,
already.
of the whole MCU plus packaging. Yeah,
Oh, okay.
yeah. It's not just wafer. Yeah, the cost has come down a lot for microcontrollers.
Yeah.
Very competitive pricing now. Yeah.
Okay, thank you.
Thank you. Yeah, so usually the price of the MCU will vary with the flash memory and the pin count. Yeah. Honestly, semiconductor is so cheap now. The wafer cost is very low. We are building on 12-inch wafers, right? So our IC cost, the wafer cost is very low. It's the packaging cost and how many pin count will cost, the price will go up. And then flash memory. Flash memory take up the most space in the microcontroller. Okay. Right now we do the M0 is very tiny. M0 is like less than 20% of the die space. Flash memory is the biggest part. ADCs, op-amps are the bigger ones. Then after that, the cost goes up with the package. Because package is really lead frame cost. Copper, iron, that's the cost that costs to us. So this is the one that this affects our pricing. Yeah. In fact, honestly, it's a microcontroller for the lower tier, right? Package is more than half the cost. The IC actually costs less than the package. Yeah. Very good question for you guys. Any other questions? Right. If not, we go on to the next topic.
Yeah.